In this video, we're going to talk about 1.3 Objective 3, where we solve trigonometric equations. I have the calculator ready because there's going to be one of the problems that I'm going to need to use it to get an approximate answer, but most of these will be able to get exact answers. So some of them, like this one, we're going to be giving answers with the period attached to them. You may not have given answers like that in the past, but we'll be doing that unless they restrict our interval for our answers. Let's go ahead and get started. So tangent is going to be negative root 3 over 3. Want an exact answer using pi. Type an angle in radians that's between 0 and pi. So tangent is going to be negative in quadrant 2. That's where they want this. And they want the tangent value to be equal to a -1 over root 3 is what that is. So opposite over adjacent, that's going to be a reference angle of pi over 6. So this is going to be 5 pi over 6. Now let's go ahead and solve here. Sine squared theta equals 12 over 16. We divide by 4, that's 3 over 4. So sine theta equals plus or minus root 3 over 2. So those would be all the places with a reference angle of pi over 3. That's pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3 when we're between 0 and 2 pi. Now cosine squared x is equal to 3 over 4. So cosine x now is equal to plus or minus root 3 over 2. And we are again between 0 and 2 pi. This time it's going to be the reference angle will be pi over 6. So it's pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now we have 2 cosine x equals 1 and cosine x equals 1/2. We want our answer to be an expression using n as the variable in the form of a plus bn, where a is between 0 and 2 pi, and the angles measured in radians using pi as needed. Use integers as fractions for numbers in the expression. Use a comma to separate answers as needed. So I'm going to have two answers here, two sets of answers. And the first one is going to be cosine is 1/2, where theta is pi over 3, plus 2 pi times n, because the period of cosine is 2 pi. And then the next place that cosine is going to be positive is going to be all the way over here in quadrant 4 with a reference angle of pi over 3, which is going to be 5 pi over 3 plus 2 pi n. All right. Now we're told that we're between 0 and 2 pi, which limits us. So 4 sine squared theta equals 1. Sine squared theta equals 1 over 4. Sine theta equals plus or minus 1/2. So our reference angle is pi over 6. Pi over 6. 5 pi over 6. 7 pi over 6. And 11 pi over 6. Okay, sine times cosine is negative root 3 over 4. I'm going to multiply both sides by 2. and make this a 2 sine, or excuse me, a sine of 2x. It's going to be a negative root 3 over 2. If x is between 0 and 2 pi, then 2x is between 0 and 4 pi. So all the places where sine is a negative root 3 over 2 on the first two revolutions, 2x is going to be equal to reference angle pi over 3 is 4 pi over 3, 5 pi over 3. Add 2 pi to this. It's going to be 10 pi over 3. Add 2 pi to this is going to be 11 pi over 3. So that means that x is going to be equal to 2 pi over 3, 5 pi over 6, 5 pi over 3, and 11 pi over 6 when I divide by 2 or multiply by 1/2 with all of those answers. So 2 pi over 3, 5 pi over 6, 5 pi over 3, 11 pi over 6. There we go. Sine of 3x. So same idea. 0 less than or equal to 3x less than 6 pi. So I need to be on the first 3 revolutions, have a sine value of root 2 over 2. That's a reference angle of 45 degrees, and it's in quadrants 1 or 2. So 3x is equal to pi over 4, 3 pi over 4. Let's add 2 pi, so that's going to be 9 pi over 4, 11 pi over 4. Let's add 2 pi again. It's going to be 17 pi over 4 and 19 pi over 4. So x is going to be equal to pi over 12, pi over 4, 3 pi over 4, 11 pi over 12, 17 pi over 12, and 19 pi over 12. It's going to be what x is equal to. Sorry. So pi over 12, pi over 4, 3 pi over 4, 11 pi over 12, 17 pi over 12, 19 pi over 12. That's B. All right. Tan squared of 2 theta is equal to 1/3. So tan of 2 theta is equal to plus or minus 1 over root 3 is equal to plus or minus root 3 over 3. 2 theta is going to be between 0 and 2 pi. So where are all the places between 0 and 2 pi where tangent has a value of plus or minus root 3 over 3 or plus or minus 1 over root 3. Let's see what our reference angle is here. So 1 over root 3, that's going to be a reference angle of pi over 6. And so that's going to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So theta is going to have to be pi over 12, 5 pi over 12, 7 pi over 12, and 11 pi over 12. Right? This is the one where I'm going to need the calculator in a minute. Where it says that I'm going to need the calculator here in a second. We'll see. So sine of 2 theta is equal to 1/3. Yes. So 2 theta is equal to arc sine of 1/3 in radians. Let's make sure I'm in radian mode. And then plus, this is going to be, the sine value was positive, and I should still keep a positive sine value here. I should be in quadrant 1, so I'm just dealing with this principal value here. So theta should be 1/2 arc sine of 1/3. 1/2 of the arc sine of 1/3. And round to 4 decimal places. So 0.1699 radians. All right, let's solve this equation here. Cosine of 3 theta is equal to 8/9. Let's make sure I got all the answers here. So I should be able to go all the way around again. That, not all the way around again, but I should be able to go to pi, and this is theta 1. 2 times theta 2 is equal to pi minus that. Okay. So pi minus arc sine of 1/3. And then we're going to divide that by 2. Theta 2 is going to be equal to 1.4009. Just so you can make sure that that's in the realm that we're interested in. There's pi over 2, and that is less than pi over 2. All right, so we're here 0 less than or equal to 3 theta less than or equal to 3 pi. So we want all the places that cosine is negative. So negative cosine values are in quadrants 2 and 3. So this is if I do our cosine of negative 8/9, I'm going to get the answer in quadrant 2, but it's going to be this angle. That's fine. That's the first one that I want. So 3 theta 1 is equal to arc cosine of negative 8/9. That is divided by 3. give me my first answer. Now my next answer comes from the same one, but if I would add 2 pi to my original, so because I'm allowed to be between 0 and 3 pi, that would be less than that. So the second answer is this plus 2 pi. So 2 pi plus arc cosine of -8/9. And that divided by 3 is going to give me 2.9830. Third answer here is going to come down here. So I'm actually going to need 2 pi minus my reference angle because I need to come this way. 2 pi minus this reference angle. So 2 pi minus our cosine of -8/9. That gives me 2 pi minus our cosine of -8/9 is what I did. When I get that, I'm going to divide that by 3. And that makes my third answer 1.2058. 2058. And I have them all in numerical order there. All right, let's do a couple more. So we wrap up here. 4 sine squared x equals 1. Sine squared x equals 1/4. Sine x equals plus or minus 1/2. Reference angle is pi over 6. That's pi over 6. 5 pi over 6. 7 pi over 6. And 11 pi over 6. Yeah, it says between 0 and 2 pi. All right, and then this one is between -pi/2 and pi/2 for my interval. So sine squared 2 theta is equal to 1/4. Sine 2 theta is equal to plus or minus 1/2. So that means -pi 2 theta to pi. All right. So 2 theta is equal to -pi and pi. So minus 1/2. So that's going to be -5 pi over 6. Then -pi over 6. Positive pi over 6. Positive 5 pi over 6. And so theta is going to be -5 pi over 12. -pi over 12. Pi over 12 and 5 pi over 12. All right, that's it for this video. And we'll come back next time and talk about 1.3 Objective 4. See you for the next video.